have HNO3, H2SO4. Both are strong acid, but this one contain only one hydrogen. That means it can release only one hydrogen at a time. So that is called the monoprotic acid. And this sulfuric acid contains two hydrogens, so that will be diprotic. So that means when it dissociates, it can release 2H plus ion. So whatever concentration of acids given, say for example if you have 1 molar acid, that will dissociate and produce 2 molar of hydrogen ions. So whenever you see concentrations, molarity, you have to multiply based on whether it is monoprotic or diprotic, like that. And also same thing for bases. Say for example you have sodium hydroxide and calcium hydroxide. Okay, sodium hydroxide is a monobasic base. It is monobasic because it has only one OH ion. But calcium hydroxide, you can see it will release what? 2 OH, so it will be dibasic. So same thing, if the concentration is 1 molar for this, OH minus will be what? You have to multiply, that will be 2 molar. Okay, you have to keep that information. Remember that while you're doing this calculation. Okay, you will see very few questions like that, but if you get a question, you have to get the correct answer. So this question, you have different acids and bases given, and you have to calculate pH and pOH. Okay, so the equations we are going to use, if you have an acid, you will get H plus ion concentration, then pH will be negative logarithm of H plus, and pOH will be negative logarithm of OH minus. If we get one of the value, we can find the other one by using the equation pH. Their sum will be equal to 40. So these are the two equations we are going to use on this practice. Okay, we already did this because why I am doing it for advanced students, they have to be very clear about the sig-fig rules because some of the questions may be free responses. Okay, here hydrochloric acid. First thing you have to write the formula to decide whether it is monoprotic or diprotic. Okay, we see the concentration and it is only one hydrogen. So this will be the concentration of what? H plus ion. So that is an acid. So we are going to find negative log of 0.023. Okay, plug that onto your calculator and get the answer. You will get 3 times 10 to the power of -5. Not that one. So let me find the answer. Okay, you will get, let me put that in the calculator and double check one more time before. So it is negative from the bottom, and then you have to substitute the log, then type 0.023. Okay, that will be 1.638. Okay, now the sig-fig rule. Okay, so we already talk about this in class. So you have to look at the concentration which has 2 sig-fig, right? So if there is a 2 sig-fig, your pH answer needed 2 decimal place. It is always the same rule. If you are going back, you have to use the same rule, okay? That means I got 1.638 in my calculator. So I needed 2 decimal place. I'm going to round my answer into 1.64. Okay, that is my pH. Then finding pOH, since we already have pH, that is very easy to subtract because we are using this equation. So subtract from pOH, sorry, 14, then you will get the answer, which is, you had to remember, you had to keep the 2 decimal place always. So that will be 12.36. That is your final answer. Okay, so then some of you are confused when the concentration is given in scientific notation. I don't know why that confusion coming from, where it is coming from. We can go write the formula HNO3. Let me go back to the other color. Okay, HNO3. So there is only one hydrogen. This is monoprotic. That means this is the concentration of H plus. Okay, so go ahead and substitute that. Negative log 6.6 times 10 to the power of negative 6. Okay, when you plug that, just do that once really quick. Put that into your calculator. You will get okay, so you will get 5.18. Okay, again look at the sigfic rule. There are 2 sigfic digits, right? Then that means we need 2 decimal place. Okay, this one, oh, that is a highlight. This one, let me erase it. This one has 2 significant digits, so we need 2 decimal places in your answer. So your answer will be 5.18 and the final answer will be 14 minus 5.18, not the final answer, the pOH, and that will be 8.82. Okay, so the next question, it's given a base which is potassium hydroxide, and that is a monobasic, so that means this is the concentration. So we are going to write negative log of, this time since it is a base, you are going to find the pOH first. So you're going to plug that onto your calculator, 0.334. Okay, so you will get an answer which is 1.476. Okay, now sigfic. This one has 3 sigfic, right? So we need 3 decimal places in your answer. Okay, that's why I kept 3 decimal places, and when you subtract 14 minus 1.476, we have to keep the same decimal place. Okay, so the answer is 12.524. Okay, so this one, it is hydroarsenic acid. There is 3 hydrogen, so it is triprotic. You can, as of now, since we didn't learn about the other equations for weak bases and weak acids, so you can just assume it is triprotic and multiply with 3, so that will become 3.0, then do the calculation. Okay, but you will not get a weak acid or weak base in your calculation on your test. So this one, it is aluminum hydroxide. Again, it is what, 3 tribasic. So what you are need to do for finding OH minus, you have to multiply this with the 3. So that will be 669 times 10 to the power of negative 2. Okay, then do negative log of 6.69 times 10 to the power of negative 2. Then get that answer. Whatever answer you are getting, subtract from 14. So you can write in I will, if it is a pH value, I will write in normal numbers instead of going into the scientific notation. So on your test, we will give specific instruction how to write your answers since it is freezer response. So it will be 12.825. So here same thing about the sig fig. Okay, there is 3 sig fig in this number. So your answer needed 3 decimal places. Okay. Now this we are going backward questions. Okay. Okay. So this time we are going to find the concentration of hydrogen ion or hydronium ion or OH minus from pH and POH. So H3O plus means it is equal to the concentration of H plus ion. We already know that. And the equations we are going to use 10 to the power of negative pH because it is a log base 10. We are taking the anti-log. That will be POH. Okay, so sig fig rule also. Okay, let's start that. Okay, pH is 2.5. You can do multiple ways. Find H plus, then find OH minus. I prefer always doing this way. POH is equal to 14 minus 2.5, right? So we will do that first. So 14 minus 2.5, then you will get 11.5. So you have both the values, then directly go find the other one. Okay. So just go to your calculator and type 10 to the power of negative 2.5. Okay, so 10 exponent negative 2.5. Then you will get the answer is 3 times 10 to the power of negative 3. Okay, 3 times 10 to the power of negative 3. Okay, now sig fig rule. We are going backwards, right? That means we have to look at the decimals. How many decimals it has? It has only one decimal. So 1 decimal, that means you need how many sig fig? Only 1 sig fig. So that's why we wrote 3 times 10 to the power of negative 3. Okay, so then do the same thing. You can do 10 to the power of negative 11.5 and find the value. Or you can also use like this equation H plus times OH minus is equal to 10 to the power of negative 14. I don't care which equation you are using. You have to get the correct answer. That is it. Okay, so it is negative 11.5. Okay, so go ahead and write the answer, which is 3 times 10 to the power of negative 12. Okay, skip the same figure. So that is a rule. So this question, okay, let me see. This question which has 2 decimal place. Okay, so that means you have to keep 2 sig fig in your answers. So if you are getting a number like 3, you have to put 3.0 to keep the sig fig. Or you can convert that into a standard form instead of keeping the scientific notation. Okay, and this is a repetition of what we just did. Okay, that's it for pH calculation.